The next rule Milo will help us learn about is conditional elimination. The more common name for this is the Latin one, modus ponens, which means the method of affirming. So the way the rule works is this: you have a conditional and you have the antecedent of the conditional. Then what the rule says is you confirm or infer the consequent of the condition. So, if you remember, Milo and I are in the grocery store, and he's arguing for more toys like it's a Supreme Court hearing. And one way you can interpret this argument is as having an implicit premise, a premise that is intended but that has been left unstated. We don't deal very much with these in this course. It's more of a topic for Phil 125. But the implicit premise here would be that 14 toys is not enough for appropriate development and maturation of a small child. That clearly any child with only 14 toys is in a state of severe material deprivation that could only be rectified with the purchasing of more toys, or something along those lines. We'll go with this. If I have only 14 toys, then I need more toys. So this would be the argument in standard form. Right? F and N, if I have only 14 toys and I need more toys, therefore I need more toys. And here's the derivation. So we have the two premises here. First step is this: we infer F by condition or by conjunction elimination. Now you can't skip this step. Remember that this is talked about this in a previous video. This is one of those bookkeeping steps that is not explicit in ordinary reasoning. You need this here because remember what the conditional elimination rule says. It says you have to have a conditional, you got that here, and you have to have the antecedent of the conditional. F and N is not the antecedent of the conditional. So you've got to get that antecedent out first with conjunction elimination. And then we can use this rule, conditional elimination, to get N. And the citation here is we cite the line that the conditional is on, and we cite the line that the antecedent is on. And the order in which you cite those doesn't actually matter. And we cite the name of the rule. So there are a couple of things you want to watch out for here. One of these is a classic fallacy called the fallacy of affirming the consequent. It's a classic fallacy because it looks like conditional elimination, but it isn't. So here, if the inference goes like this: if John is in Toronto, he is in Canada. John is in Canada, therefore John is in Toronto. Right? If T, then C, C, therefore T. So you have the conditional, you have the consequent of the conditional, and then you infer the antecedent. This is not a valid argument. Right? I know that there are a lot of people in Toronto. I lived in Toronto for a while, and there are a lot of people there who think that the western border of the nation is basically Mississauga, but this is not in fact true, and this is not a valid argument. Another one to watch out for is the fallacy of denying the antecedent. If John is in Toronto, he is in Canada. True premise here: John is not in Toronto, therefore John is not in Canada. So here you have the negation of the antecedent, and then you infer that the consequent has to be false. And again, this is not a valid argument. The fact that the antecedent is false doesn't mean that the consequent has to be false. The consequent could be true for other reasons besides the antecedent. Seems to me that the best way to get people in Western Canada not to commit a fallacy is to tell them that people in Toronto do it. Last one is that this is not a classical fallacy, but this is something the logical students do all the time. You can just call it the fallacy of inferring the antecedent for no reason. If John is in Toronto, he is in Canada. So then the step is this: we have the antecedent, then the consequent. The person infers the antecedent for no reason whatsoever, and then they infer the consequent. Um, this is a desperation move. This is the kind of thing that people do when they're they're staring at a derivation. It has a conditional in it. They don't know what they're going to do, and so they just start inferring things. and they think that this is going to help them get somewhere. And it doesn't, is the thing. When we get to talking about strategy, we'll talk about the kind of things that you need to do in order to avoid getting so desperate that you make moves like this. Okay. The next rule that we'll look at is disjunction introduction. Another name for this rule that you'll find is addition. So if a sentence is true, sentence P is true, then P or anything else must also be true. So you can infer P or Q is any other sentence, or you can infer Q or P, right? The disjunction, you can put the new disjunct on either side of the disjunction. This is a bookkeeping rule, not made explicit in ordinary reasoning. It's there primarily to make sure the sentences, it allows you to weaken sentences when you need to do that in order to apply another rule. This is the primary function that it has. So, for example, you have this argument. If Trudeau can't reduce inflation or goes on more free Christmas vacations, then Poilievre will be elected. Trudeau can't reduce inflation, so Poilievre will be elected. This video apparently just turned into the Western Alienation 101. So here's our symbolization key. This is the argument in standard form. Here's how the derivation will start off. Now, just notice here, what you'd like to be able to do is solve this using conditional elimination, because we have not R here, right? Trudeau won't reduce inflation. We want to be able to get to P, right, which is the conclusion of the argument. But remember that what conditional elimination says is you have to have the conditional and the antecedent of the conditional. The antecedent of the conditional is not R, it's this. So to get there, what you have to do is you have to use disjunction introduction to get the antecedent of the conditional. The antecedent of the conditional is weaker than what we have here. It says that there are two possible ways that you could get the consequent. We have one of the ways, so we use disjunction introduction to say basically, well, since we have one of the ways, we have, one of the two possible ways. That's what we're doing here. And then we can use conditional elimination to get to the consequent of the conditional. So that is how the conditional elimination and disjunction introduction rules work.